All right, let's dive into this one. Fritjof Capra's The Tao of Physics. You sent this in, so we're going to take a deep dive
Yeah.
and, yeah, explore these wild ideas about modern physics and Eastern mysticism and how they kind of seem to be saying similar things about the universe.
Yeah, it's pretty amazing how Capra brings these two worlds together. They seem so different at first glance.
Right, like physics is all about equations and experiments and, hard data, and
Hmm.
mysticism is, all about meditation and intuition.
Exactly. But Capra, he finds these surprising connections between them.
So in the Tao of Physics, he's really looking at the parallels between how modern physicists are, understanding the universe and this ancient wisdom in traditions like Hinduism, Buddhism, and Taoism.
Right.
And today, we're going to kind of unpack some of these key concepts and highlight the most intriguing connections and hopefully leave you with some, interesting ideas to ponder.
Sounds good to me.
Okay, so right from the beginning, Capra shares this personal experience that really kind of sets the stage for the whole book. He's talking about being on a beach, and he suddenly, sees the universe, engaged in this incredible cosmic dance.
Oh, yeah, like the dance of Shiva.
Yeah, exactly. The Hindu god, Shiva.
Well, it's not just a poetic image, though. Capra uses it as this metaphor for his central argument.
Hmm.
Modern physics, it shows us that the universe is in constant motion, constant transformation. And, this idea has been at the heart of Eastern mystical traditions for centuries.
So it's like physics is finally catching up to what the mystics have been saying all along.
Yeah, it's an interesting way to think about it.
That's pretty cool. But there's a catch, right?
What's that?
Both physics and mysticism, they really struggle to describe these profound concepts using, everyday language.
Oh, absolutely. Capra really highlights this challenge. I mean, how do you use words to explain something that fundamentally defies description?
Right. It's like, how do you describe the taste of chocolate using only words?
Yeah,
You can get close, but you can't really fully convey the experience.
right, exactly.
And even brilliant minds like Heisenberg, the famous physicist,
Yeah.
even he admitted that every word, every concept we use, no matter how clear it seems, it has limits.
Right.
And Capra quotes D.T. Suzuki, who basically says the same thing about trying to explain the essence of Buddhism.
Yeah.
So it's fascinating how both physics and Eastern mysticism have had to find ways around these limitations of language.
Right.
And, it makes me think of those Zen coins.
Oh, yeah.
Those riddles designed to short-circuit your logical mind, right? They're like little puzzles that force you to think outside the box, see beyond the limitations of language.
And, Capra suggests that those coins, they're not that different from the paradoxes that physicists encounter when they're dealing with quantum mechanics.
Oh, interesting.
They're both trying to kind of nudge us towards a deeper understanding, a recognition that reality is far more complex and nuanced than our everyday language can capture.
Okay, that's cool. But before we go too deep into the mystical side of things, let's maybe just ground ourselves in the physics for a moment.
Okay, sure.
So Capra talks about this, major shift in how we understand the universe, right?
Yeah.
From that old clockwork model of Newtonian physics to the more dynamic world of modern physics.
Right. It's like trading in your old-fashioned pocket watch, where everything ticks along predictably for something more like a lava lamp.
Oh, yeah.
Where things are constantly bubbling and changing.
Yeah.
See, Newton's universe was all about absolute space and time, with matter as these solid, unchanging objects.
Right. Very fixed and predictable.
Exactly. And then Einstein comes along with his theory of relativity, completely shaking things up.
Yeah. Relativity. It changes everything.
It does. It really does. He's basically saying, hold on, space and time are actually linked. They're not absolute. They're relative to the observer.
Whoa, okay.
Yeah, it's a real mind bender, but essentially it means your perception of time and space is influenced by your motion and position.
So time is not this constant thing that's ticking away the same for everyone everywhere.
Not exactly, no.
Wow.
And here's the real kicker. Einstein shows that this linkage of space and time, what we call space-time, is actually warped by the presence of matter.
Okay, no, you're losing me. Space-time is warped. What does that even mean?
Think of it like this. Imagine a bowling ball on a trampoline. It creates a dip, right?
Right.
Well, in a similar way, matter distorts the fabric of space-time.
Okay, that's a cool visual. So the universe is like this giant trampoline, and all the stars and planets are making it sag in certain places.
It's a simplification, but it gives you a sense of it.
Okay, I think I'm starting to get it. But then quantum theory comes along and says, hold on, It's even weirder than that.
Oh yeah, quantum theory throws another wrench into the works.
So what does quantum theory say? What's so weird about it?
Well, instead of picturing these nice, solid little balls of matter, quantum theory says that we need to think of matter as these, like, wave-like patterns of probabilities.
Probabilities. So things aren't even really solid anymore. It's all about chance.
In a way, yes. Those solid objects that we thought we knew so well, suddenly they become fuzzy and uncertain.
Okay, my head is officially spinning.
No.
So we've gone from the clockwork universe to this, like, warp trampoline to a fuzzy world of probabilities.
And that's just the beginning.
Oh, boy.
But the key takeaway here is that this classical idea of certainty, it goes out the window. It's all about probabilities and uncertainty at this subatomic level.
So the universe is basically just a giant game of chance.
Well, not exactly random chaos, but definitely a lot more dynamic and uncertain than we used to think.
Okay. And I'm sensing this is where that dynamic interconnectedness we were talking about really comes into play, right?
Exactly. Both modern physics and Eastern mysticism seem to be converging on this idea that the universe is fundamentally dynamic and interconnected.
Okay, so it's not just random chaos. There's an underlying connection, a flow to it all.
Right. And Capra illustrates this beautifully throughout the book.
So give us some examples of the, like, mind-blowing connections he makes.
Well, think about the expanding universe and the Big Bang Theory, for instance. This idea that the universe started from a single point and has been constantly expanding and evolving ever since.
Right.
Then there's this view of matter as patterns of energy, constantly transforming and interacting, never truly at rest.
Okay, so this dance of energy and transformation is happening at the, like, cosmic level.
Mm-hmm.
But then Capra takes us even deeper, right? He zooms in on the quantum realm. That's where things get really strange with this whole idea of the quantum field.
Yes, imagine this quantum field as this underlying ground of being, this very fabric of reality from which particles emerge and dissolve.
Okay, I'm picturing this, like, field of pure potential. But it's not just sitting there static, right? It's dynamic, alive with possibilities.
Definitely not static. It's like a vast ocean of potentiality constantly bubbling with activity.
I like that. So particles are constantly popping in and out of existence within this field.
Yes, like bubbles in a boiling cauldron.
And this is where he connects it to the void in Taoism, right?
Exactly. That concept of emptiness that's not actually empty but full of potential, the source of all creation.
Okay, so it's like the universe is constantly breathing in and out, creating and dissolving in this never-ending dance of energy and form.
Yeah, that's a great way to put it.
Wow, that's a powerful image.
It is, isn't it?
It reminds me of that famous Buddhist saying, form is emptiness. Emptiness is indeed form.
Yes. It's like those seemingly opposite concepts are actually two sides of the same coin.
Just like in the quantum field where particles emerge from the void and dissolve back into it, it's mind-blowing how physics is starting to sound more and more like Eastern mysticism.
All right. It's incredible.
I'm ready for more. What's next in this cosmic adventure?
Next, Capra takes us deeper into the world of particle physics. It's a wild ride.
Oh, I'm ready. Bring on the particles. So what's so special about this world? Why particle physics?
Well, imagine you're looking through a microscope at a drop of water, and you suddenly see all these tiny creatures swimming around, bacteria, amoebas, living their own little lives.
Okay, yeah.
Particle physics is kind of like that, but on a much, much smaller scale. We're talking the building blocks of matter. Particles so small you can't even imagine.
So it's like there's a whole universe happening right under our noses, but we can't see it.
Exactly. And just like in that drop of water, there's this constant dance of creation, annihilation, and transformation happening in the particle world. Capra even describes these amazing photographs called bubble chamber photographs. They're like snapshots of the subatomic world. You see these tracks of particles appearing, disappearing, colliding, transforming. It's like watching the universe breathe.
So it's not just some static picture. It's a dynamic process full of, energy and movement.
Exact.
I can see how that ties into the idea of the cosmic dance we were talking about earlier.
Right.
But what are these particles actually doing? What's the point of all this activity?
That is the question, isn't it? And one of the key players in this subatomic dance is something called virtual particles.
Virtual particles. Okay, what are those? Do they exist only in, like, virtual reality?
No, not exactly. They're not exactly like the particles that make up you and me. Think of them more like tiny bursts of energy that pop in and out of existence, almost like those bubbles in the quantum field we talked about earlier.
Okay, so they're like fleeting sparks of energy, but if they're constantly appearing and disappearing, what are they actually, like, doing?
Well, they play a crucial role in the interactions between particles. Imagine them like invisible springs connecting everything, constantly pushing, pulling, exchanging energy, influencing how other particles behave.
So they're like the glue that holds the subatomic world together.
You could say that, yeah. And here's the kicker. They do all of this while never truly being at rest. It's constant, dynamic interplay, a never-ending exchange of energy.
Okay, my brain is starting to hurt a little bit. But in all of this chaos, is there any rhyme or reason? Are there like patterns or rules governing this subatomic world?
Well, yes. While it may seem chaotic at first, physicists are constantly searching for those hidden patterns, the underlying laws that govern this subatomic dance. And Capra talks about the search for symmetries and patterns in the particle world. He mentions this fascinating theory called S-matrix theory. It focuses less on the particles themselves and more on the relationships and interactions between them.
So it's less about the individual dancers and more about the choreography of the dance itself.
Exactly. And that shift in perspective, is one of the core connections to Eastern thought. The idea that the whole is greater than the sum of its parts, that relationships define reality.
Okay, yeah. It takes two to tango. Or, in this case, a whole web of interconnected particles to create the universe as we know it.
Well put.
But speaking of particles, Capra throws in another curveball, right? He mentions these things called quarks.
Yes, the mysterious quarks.
They're like these theoretical building blocks of other particles, but they've never actually been observed on their own.
Right, they're like ninja warriors working behind the scenes, influencing the structure of matter, but never revealing their true faces.
So they're both there and not there at the same time. Another paradox.
Exactly. Another paradox to add to our list.
But this idea of quarks, being these elusive entities, always interconnected, it leads to one of the most mind-blowing concepts in the whole book, the bootstrap hypothesis.
Yes. The bootstrap hypothesis. Now we're getting to the heart of it. It's this radical idea that there are no truly fundamental particles, no ultimate building blocks. Instead, each particle, it gets its properties from its interactions with all other particles.
Hold on, let me wrap my head around this. So instead of thinking of particles like Lego bricks, where you have these basic blocks you can put together to build something bigger, you're saying it's more like a giant game of tag.
I love that analogy. It's like a cosmic game of tag where everyone's it at the same time. Each particle is both defining and being defined by its relationships with all the others.
Whoa, okay, so it's like a self-consistent web where everything is interconnected and interdependent.
Exactly. And here's where Capra draws those strong parallels to Eastern philosophical ideas, like the Buddhist concept of interpenetration, where each part contains the whole. He also uses that beautiful metaphor of Indra's net. It's this vast web of jewels, and each one reflects all the others infinitely. This stunning image of this interconnected reality.
Okay, my mind is officially blown.
Yeah.
But if everything is, like, bootstrapped, if there are no fundamental building blocks, does that mean the universe just explains itself? Isn't that a bit circular?
Well, that's where the bootstrap hypothesis gets really philosophical, and Capra doesn't shy away from those deeper questions. He points out that even with the bootstrap, science as we know it still needs some kind of framework, some basic assumptions to work from. It's like needing a canvas to paint on, even if you're creating a masterpiece of abstract art.
Okay, so there have to be some ground rules, some starting point.
Exactly. And that's one of the key takeaways here. Both physics and Eastern mysticism, they're pushing us to the very edge of what we can know and express, forcing us to confront the limitations of our conventional thinking.
So they're both peering into the abyss of, like, ultimate reality, but they're doing it from opposite sides of the mountain.
I love that image. And it's in those glimpses, those moments of insight, where the parallels become most clear.
So we've talked about how both physics and Eastern mysticism see the universe as this dynamic, interconnected web, constantly in flux, defying simple categorization. But Capra doesn't stop there, right? He explores what this all means for us. How this worldview affects our understanding of ourselves, our place in the universe.
Absolutely. And that's where things get even more interesting.
Oh, I can't wait to hear more.
Yeah, it's fascinating. It really makes you wonder, what other connections are out there just waiting to be discovered.
Right. It really opens up a whole new way of looking at the world. And this brings us back to, this theme that Capra keeps returning to throughout the book. The limitations of language when it comes to describing the true nature of reality.
Yeah, it's like we're trying to, capture lightning in a bottle, to use words to describe something that's ultimately beyond words.
Right, like, that Zen saying, those who know don't speak, those who speak don't know.
Exactly. Both physicists and mystics, they find themselves struggling to express those profound experiences and insights. It's like trying to describe the taste of, I don't know, some exotic fruit to someone who's never experienced it.
Yeah, you can use all the adjectives in the world, but they won't really get it until they taste it for themselves.
Exactly.
And this is where I think Capra's skill as a writer really shines. He doesn't just throw all this complex scientific stuff at us. He uses analogies, metaphors, personal anecdotes, all those things to make these mind-boggling ideas more accessible.
Yeah, he's like this master weaver, blending the scientific insights with philosophical reflections and mystical experiences to create this tapestry that's both intellectually stimulating and profoundly moving.
So it's not just a journey through physics, it's like a journey through human consciousness.
I like that.
And one of the, I think, most significant things we learn on that journey is, we're not separate from the universe. We're participants, not just spectators. Our observations, our very presence, are shaping reality.
It's wild, isn't it?
Yeah, it's humbling,
Huh?
to realize we're not at the center of everything. But it's also, kind of empowering because it means we have a role to play,
Sure.
that our choices matter.
That's a good point.
And that's really the ultimate message of the Tao of Physics.
Right.
This call to recognize our interconnectedness with all things. Embrace the dynamism, the uncertainty. Approach life with wonder and awe.
It's a message that I think really resonates today, where we often feel so disconnected from nature, from each other, even from ourselves. Like we've forgotten that we're a part of something so much bigger.
Right, yeah. And that's where Capra's work is so powerful. He bridges this gap between science and spirituality. He invites us to see the world with new eyes, find our place in this grand scheme of things.
It's a powerful thing.
Well, he's given us a lot to think about today. The Tao of Physics. It's a book that really stays with you. It challenges you to question your assumptions, explore new ways of thinking, live a more conscious, connected life.
It's a deep dive into the nature of reality that, leaves you with more questions than answers, but also with this profound sense of wonder and possibility.
And all our listeners, if you're looking for a mind-bending exploration that might just change how you see the world, I think we both highly recommend checking out the Tao of Physics for yourself.
Absolutely, it's a must-read.
Okay, well, that wraps up our deep dive into Fritjof Capra's masterpiece.
Thanks for taking this journey with us.
And until next time, keep exploring.